Hi, this is TB from Sensorica. I will present you a protoboard shield for an Arduino that we developed for industrial IoT, Internet of Things applications. So essentially this board integrates a bunch of sensors for monitoring of industrial equipment and industrial processes, sending data to the cloud using first of all an Arduino board and a Raspberry Pi, using an XB radio communication device. So this board mounts on top of the Arduino, so it is a shield. And just go over the philosophy of these things. So we are still developing this sensor node. Arduino and the shield makes a sensor node, and we're trying to reduce the cost of these things. And since we're still in development, we thought about designing a protoboard that is very easy to debug. So we clustered all the sensors in a way that are separate from each other and can be easily serviced. And we added here a sort of a potential buffer, where if we add new sensors, we'll just add them to this little pad here and connect them somehow in the back to the Arduino. So this gives an extensibility of this already set architecture here for further changes. So we expect a few iterations working with the sensors. We might try new things here, and as soon as the new board gets more stable, we're going to change the whole design and print another PCB for it, and so on and so on. So that's the idea, and that's the philosophy here. Design something with a buffer for new potential, a place, a sandbox for experimentation with other sensors, and hopefully as these new sensors get pulled into the main design, we'll go into another iteration of PCB design. Fast going over it. What this does, essentially, it has 3 one-wire thermocouples that are shifted up with a logic signal shifter here. Then we have the connector in the back here for another infrared non-contact temperature sensor. We have ports here for a load cell, for example, that senses the pressure. We have another one for an RPM. An RPM sensor that we designed. It's a Sensorica designed RPM sensor, optically, that functions with an optical sensor. And here we have the ports in the back to power solenoid. The whole power, 12 volt, 5 amps, comes here to feed the whole board, including the Arduino. And so we control a solenoid valve from here, and we also have an entry for a fluid level sensor. Okay, power in, solenoid fluid level sensor. So this is about management of some fluid tank, monitoring of the fluid level, counting of how much stuff is flowing in there, temperature sensors, RPM sensors, and there you go. So this is how the board looks like. And this is our first version to be tested on a test bench at our sponsor's site pretty soon, and we'll keep you updated. Thank you very much.